Hi, I'm Leif from Leif Labs, and it's time to take this RC time Arduino stuff to the next level. We're going to start doing more science. So this is the same schematic from the previous video, but now in parallel to my 10 kilo ohm resistor, I've added a pair of electrodes that go into some water. So I have, to do this is actually extremely straightforward. I just have on the solderless breadboard these two jumpers that plug in going across in parallel to the resistor, and then here I take them and I put them in this dish like this. It's really just a dish of water. In order to do this, I'm going to load a new program which is very similar to the old program, but I've changed a couple of little things around. So in the old program, what we were doing is just measuring voltage and then putting that down the serial and plotting it. But now what we're going to do is every time you hit the upper threshold, what you're going to do is reset this counter n to 0, and you're going to print whatever it is. So what this means is that you go up to the upper threshold, you set n equal to 0 here, and then you go down, 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 hit the threshold, go back up, and then when you get here, you're going to set n equal to 0 again, but when you do this, you're going to take the n, which represents how many counts there are between these points, and you're going to put it down the serial. So what you're getting then is the period, which I'll call capital T, the period of this waveform. So if I make sure the waveform, if I lower the threshold a whole bunch so that the waveform gets closer and closer to a triangle wave, then that triangle wave has a period, which should be linear, mostly linear, in the RC constant. So if you fix C and measure R or vice versa, then that number n, which represents this period t, is essentially a measurement of that quantity, either R or C. So in this case, we're going to keep C fixed and we're going to vary R. And that's precisely what I do with these two electrodes. So I'm going to take these and I'm going to lower them slowly into the water. Well, watch what happens as I lower these slowly into the water. So now looking at the graph, I can see that I can go up and then back down. What I'm doing is exactly what I showed a minute ago, where I move the two electrodes up and down, in and out of the water. And so I've made it a little level sensor. Essentially, in the crudest possible sense, what I can just do is say this is telling me how deep the electrodes are into the water. But you can see this is a probe that can be used for much more than that. A level sensor is useful. They're actually incredibly useful in the lab. But I could also imagine having them to be totally immersed, and I could do something like measure a gradient in the conductivity of the water as a function of position. So if there's, say, a salinity gradient, then you can measure that salinity gradient. So I think you could design fairly easily some experiments where you have different shapes of salt water. You put a whole bunch of salt at one end, and then you could measure the diffusion by moving this thing around and seeing how the salt diffuses. So what's happened here is that by doing essentially the same experiment as in the last video, I've opened up the entire world of electrochemistry and a whole bunch of kind of fluid dynamics and so on that is still just using the Arduino with this simple RC circuit. So hopefully this will be a jumping off point for a whole bunch more science, and we'll get to that shortly, but this should be enough to kind of split the project into a whole bunch of different possible projects that you could do for this. So thank you for listening, like and subscribe.